Welcome to recording 1B in our series on solving systems of equations algebraically for Unit 8, Chapter 8 of Mathematics 2200. Here we'll be solving systems of equations using elimination. So we'll start with the same example we did in recording 1A when we did it by substitution. First thing I usually do is align the like terms over each other. So 2x and 6x, for example, are like terms. Negative 2y and y are like terms. The constants are like terms. So I have 2x minus 2y plus 2 equals 0. Meanwhile, I don't have a like term to go with the x squared from the second equation, so that guy is off by itself a little bit. Minus 6x here. And then the negative 2y lines up with the positive y that I have and the plus 3. So all I've done is align my like terms. I guess I better put that equals 0 there, and I put the comment in here now. Next thing I want to do is eliminate y. So I'm going to do that across here. How do I do that, you say? Well, let's see. One way to do that is to set it up so that when I add these two equations, I'll have a positive y and a negative y, but they have the same coefficient otherwise. So this one already has a negative 2y. I'll make this one a positive 2y. So I multiply that entire equation by 2, and I've got 2x squared minus 12x plus 2y plus 6 equals 0. Meanwhile, the first equation only needs to be multiplied by 1, really. And I've got 2x minus 2y plus 2 equals 0 there. Now our goal here is to eliminate a variable so that we're only left with one variable to worry about. In this case, the negative 2y and the 2y will eliminate when I add these equations. So I've got 2x squared. 2x minus 12x is negative 10x, and 2 plus 6 is 8 equals 0. I now focus on solving the resulting equation, 2x squared minus 10x plus 8 equals 0. I can either divide everything by 2 here, or I think this time I'll just take out the common factor of 2, be left with x squared minus 5x plus 4 here. All that's equal to 0. So going over to a new slide, I've got 2 outside of x squared minus 5x plus 4 equals 0. That gives me 2 outside of x minus 1, x minus 4 for my factors. So I got x equals 1, x equals 4. Now we still have to find the y values for the points of intersection. Going back to our original system, we've got 2x minus 2y plus 2 equals 0. That's a little easier equation to work with than the other one. So we've got 2 times 1 minus 2y plus 2 equals 0 here. Moving my 2y across the equal sign, I'll have 2 times 1 plus 2 equals 2y. That gives me 4 equals 2y. Divide both sides by 2. I get 2 equals y. So move things up a little bit here to get a bit more room. I have a point of intersection at 1, 2. Doing something similar with the x equals 4, I get 5 for my y value, and the point of intersection is 4, 5. Now I checked these same solutions when we did substitution in the previous recording. I leave them for you to do for yourself now. Here we have a system of quadratic equations. The procedure, though, is much the same as it was in the previous example. We align the like terms, and then our goal is to eliminate y's. So I'll do that. Let's see. We need to eliminate the y. I got a positive 2y here and a negative 3y here. So I think I'll make this one a positive 6y by multiplying the equation by 3. And the second equation, I'll multiply by 2. That gives me these two resulting equations. I now add them up, and I've got 18x squared plus 144x. The y's are now gone, they're eliminated. It's what we wanted, equals negative 270. We solve the resulting equation. Solve the resulting equation. I can bring that 270 across the equal sign. I've got 18x squared plus 144x plus 270 equals 0. I can take out a common factor like I did in the last example. I've got 18 outside of x squared plus 8x plus 15 equals 0. Over on this new slide, this factors, the x squared plus 8x plus 15 factors quite nicely as x plus 3, x plus 5. So we get two possible answers, x equals negative 3, x equals negative 5. Now we have to choose an equation to substitute into, so we get the y value. They're both quadratic, not much difference in the difficulty level. I'll choose this one simply because the coefficient of my y is positive. So putting negative 3 in place of x in my first equation, I've got 4 times 9 minus 96 plus 2y equals negative 52. And that gives me 36 minus 96 is negative 60 plus 2y equals negative 52. 2y equals 8, y equals 4. So negative 3, 4 would be a point of intersection. And I've just completed the substitution for negative 5, and we get negative 5, 4 for the other one. The checks, again, are left for you. Now, in summary, to solve a system of equations using elimination, align the like terms, multiply each equation by the necessary values to eliminate y when they're added, add your two equations, solve the resulting equation for x, and use those values of x to get the values of y, write solutions as points of intersection, check your point of intersection in both original equations.